Hello everyone, welcome to my channel Chemistry is Fun. I am Kakoli Nandi inviting you all to my channel. I am very sorry that I am posting this video after a long span of time because of some personal commitments. But I assure you all that henceforth I will be regularly uploading videos regarding chemistry. The topics will be of 11th standard, 12th standard and also for IIT preparation. Today we will be dealing in the wave particle duality of electromagnetic radiation. James Maxwell had stated that whenever charged particle is under motion and is experiencing some acceleration, alternating electrical and magnetic fields are produced. They are transmitted in the form of waves. We can call them electromagnetic waves or electromagnetic radiations. The charged particles, when they are oscillating, they will produce oscillating electric field as well as oscillating magnetic field. These fields are perpendicular to each other and they are also perpendicular to the direction of wave propagation. As we can see in this figure, you can see that along x-axis this is the direction of propagation of the electromagnetic radiation. Here along the z-axis we have the electric field component and another one is the magnetic field component. They all are perpendicular to each other. There are certain characteristic properties of the electromagnetic waves. The first is that they do not require any material medium for propagation. They can propagate in vacuum. The different types of electromagnetic radiations differ from each other in wavelength. They all together constitute the electromagnetic spectrum. All the radiations have a particular wavelength denoted by lambda and frequency. The SI unit for frequency is hertz. The SI unit of wavelength is meter. If we multiply both, we get the speed, that is product of wavelength and frequency. There is another characteristic property associated with the wave nature, that is wave number. It is defined as number of wavelengths in 1 unit length. That is, in 1 unit length how many wavelengths can be fitted, that will be giving the wave number for that particular wave. There are certain characteristic features which cannot be explained by the wave nature of electromagnetic radiation. For that, particle nature is important. With the help of particle nature, we can explain photoelectric effect, line spectra of some atoms like hydrogen, as well as black body radiation. First, let us deal with photoelectric effect. Whenever any metal, certain metals, they are exposed to radiation, electrons are ejected. This is called photoelectric effect. That is, on the surface, if this is the surface of the metal, on that particular radiation is striking. If the radiation is having frequency nu, its energy will be h nu, E is equal to h nu. So as soon as the radiation strikes the surface, electrons are ejected. This phenomena is called photoelectric effect. There will be no time lag. As soon as the radiation falls on the surface, immediately electrons will be ejected. The number of electrons which are ejected depends upon the intensity of the light. Number of electrons. It is related to light intensity. Whereas the kinetic energy of the ejected electron will depend upon the frequency. As I told you, E is equal to h nu. That is, if the energy of the radiation which is falling on the surface is given by h nu, a part of it will be utilized to eject the electron. That will be given by h nu naught, where nu naught is the minimum frequency called threshold frequency. This is the minimum amount of energy required to eject the electron. If the frequency is less than nu naught, electron will not be ejected. The energy which is hitting the surface is h nu, which is greater than h nu naught. That is, nu is greater than nu naught. So when energy is given as h nu, a part of it, that is h nu naught component, will be utilized to eject the electron, and rest of the energy will provide kinetic energy to the electrons. That will be given by half MeV square, where Me is the mass of the electrons. So the extra energy which is left out will be providing kinetic energy to the ejected electrons. Now, using Millikan's oil drop experiment, which had shown the particle nature, and the diffraction study which showed the wave nature, de Broglie had also given the dual nature of electron as well. That is, electron can also be stated as a material particle and a wave. So regarding that electrons, we can give de Broglie's equation as lambda equal to h by p. P is stated as m into v. So lambda equal to h by mv. Using this, we can calculate the momentum of the particle, where the mass is m and it is moving with a velocity v. This de Broglie's equation stated in the end by me is for dual nature of electron. Thank you for watching my video. I will be uploading more videos related to the topics in the coming days. Please support me by subscribing my channel. Thank you.